Hey everybody, this is Alex Merced from alexmercedcoder.com, and in this video what I want to do is just kind of make recursion make more sense. I've done videos on recursion before, but I thought I would do it again to help understand, because at the end of the day, like, think of recursion just as a weird way of doing a loop. That's literally all it is. So let's just do a loop real quick. So let me just click in here. Okay, so if we wanted to do just a normal loop, we'll just say let x equals 0. And then what would happen is we would say while x is less than 10. And then we'll just say console.log 10 or console.log x. And we'll just add 1 to x. And then this will result in a console log running 3 times. So escape, you go down here, and I do have like the Vim extension on VS Code, so bear with me. I just did it this morning, so still kind of getting used to all the Vim commands. But let's see here, node scratch 2.js, and see, it just loops. That's, at the end of the day, you can, it's recursion. What you're doing is you're replicating all this thing, because all a loop is you're essentially just running this function here as long as this expression is true. That's literally all it is. So let's try to create a function that does the same thing. So we'll say const while, okay, const while recursive, and we'll just pass in a number saying, hey, you want to loop this many times. Okay. And where do we start the counter? So we'll say start and end. That's going to be sort of our 2 parameters. Okay. And basically what's going to happen is that it's going to say if start equals the end, so meaning basically if there's no more loops, then we'll just say return 0. It's just done. Okay, else what I wanted to do is I wanted to console.log the start variable. So console log the number that we're in right now. And then what it's going to do, it's going to return itself. I'm going to run while recursive again. Except now, instead of passing in start as the same number, I'm going to say start plus 1 and pass in the same end. Okay, it's the same thing. It's just basically, it's going to keep doing it until start equals end. So if I do this, while recursive, and I want to start at 0 and count up to 10, we'll see, it'll do the same thing. See, it ends up doing the same thing. Because on the first round, so you see it goes 0, 1 through 9, then 0, 1 through 9. Because the first time it's 0. Does 0 equal 10? No. So in that case, it does the else, it console log 0. Then it runs the function again, except now it's 1 and 10. Then 2 and 10, then 3 and 10, then 4 and 10, then 5 and 10, then 6 and 10, then 7 and 10, then 8 and 10, then 9 and 10, and 10. It's the same thing as this loop. Now this looks a little bit more complicated. Like I wrote, this was definitely a little bit more verbose than this while. So I would say for 90% of the time you need a loop. A loop is probably the better way to go, but there are going to be some times where, you know, doing it recursively might make more sense. It actually will trim down the amount of code that you need to do. Okay. So, and then I could have also written this in a more succinct way. I could have used a ternary operator, so let's try that. So let's do this. We'll just say you always console.log start, so it's always going to happen, and then return start equals end, and if start equals end, return 0, and if it's false, then return while recursive start plus 1 end. Okay, so now this is starting to become a little bit more succinct. Okay. So now using ternary operators, we can kind of clean that up a little bit more. And we did. See, there it goes. This is something kind of 10. But let's see here. I mean, if you wanted to make sure that only counts up to 9, I could just change this to make sure that start is start. Is start equal like n minus 1. If I want to get the exact same effect. And that'll count down to the 9. Okay. But you guys get the idea. I can it's recursively, there's no loops. But at the end of under the hood, like a loop is just really like you're just running the function, except it's running the function separate times. This curly bracket. In this case, you're running the function in another function. And this is where you start getting into like this could actually be really fast memory-wise. But you run into an issue. That if it recurses too many times, you run out of a portion of your memory called the stack. And this is what's referred to as a stack overflow. Because basically what happens every time a new function runs, it gets put on this like stack of pieces of, like imagine like a stack is a stack of pancakes. Okay? And you keep, and so basically every time a new function runs within another function, that gets put on the stack of pancakes. And there's a little bit of memory that's allocated to it. So it's possible that you run so many functions and none of those functions finish, because basically when one of those functions finish, it gets removed off the pile of pancakes. So you free up, the pile of pancakes is no longer so unstable. You overflow, and this is what's referred to as a stack overflow, like the website Stack Overflow. Okay, if you want to know more about that, watch my video on the stack and the heap. But yeah, so that's all recursion is. It's a loop. Okay, but all you're doing is just saying like, hey, if the condition is met, end the function. If not, do it again. And then basically the idea is that it should end once it meets the last recursive call, and return the result of the last recursive call, because it creates like for example, let's try to do like reversing a string. Like this was a really good example that really made recursion like click for me the other day. Okay, so let me see here. Const reverse string. Okay, you pass it a string. Okay. And essentially what you want to do is do split the string. So we'll say const, I mean, I think it was a little bit simpler the one that I saw before, but I'm just doing this off the top of my head. Const would take the string, well, const stir equals, we'll call this stir r because it's an array that's made up from the string, equals string dot split. So we get an array of that, and then we're going to ask ourselves, is this array empty? Okay. And then we're going to console log it so we can see how it changes after each loop. So console.log stir r. Now if stir r, okay, and you're generally going to want to have a starting sort of value we want to return. So I'm going to actually, we want to do like a cumulative operation. So I'm going to have a starting, we're going to call start an empty start is just start. And you'll see like if stir r, no, if stir r dot length equals 0, then we're going to return start, because basically start should be the reverse string, because you're passing in what you've done so far to the next function. And then else, what we're going to do is you're going to return the last item, so stir r dot length minus 1, so that should give you back the last item in the array, plus, and then we run the function again, reverse string, except now the string we're going to pass will be the result. We'll pass in sort of like everything but the last letter. So basically, that would be stir r dot slice, and then it's going to be up starting from 0 up to but not including stir r dot length -1. Oh wait, and then we need to do start here. Actually, let me think about that for a second. We should probably do this way. So let's get rid of this. First, we should grab the first letter, last letter. So const new string. Const new string, and the way it was done that I saw earlier was a lot simpler than this, but this is just me freewheeling it. New string equals the start plus the last letter, which is stir r. Stir r dot length. Stir r dot length -1. So it's basically whatever the last item is, because we're trying to reverse the string. Okay, so that's like the new string so far. And then what we're going to do is we're going to grab the string except for the last letter. So const remaining equals stir r dot splice. So actually I can just copy this from here. So this way we can make this a little bit more explicit. Oh, that's right. I'm using the Vim thing, so I just gotta do it this way. Okay, so basically now we're passing in. We are now no longer reversing the full string, we're reversing the remaining string. And we're starting from the new string. Okay, and that should do it. So essentially what's going to happen is that it grabs the last letter, adds it to the beginning of the string, then it just keeps running the function again, which keeps grabbing the last letter until there's no more letters left. So let's try that out. Reverse string Alex Merced. Let's see if it does the thing. And I want to console log that result. Console.log the result of reverse string, because I didn't console. Yeah, so let's just do the thing. Get into an error. Figure that might be possible. Reverse string is string.split is not a function. String reverse string. Well, I passed it a string, so string can be split. But let me just do this. Maybe it's just do stir. Okay. And then I'm going to just make this default to an empty string, because that'd be silly to ask people to like enter an empty string by default. Okay, they didn't like that either. So let's see here. Stir.split is not a function. Reverse string. Now why is that not a function? Let's console log what stir is. I'm sure it's gonna be something really silly, because that's always the case. Oh no, oh, I see. It's working. Because see, we see the console log there. But I see, I forgot to, the remaining is not a string, it's an array after that first time. I forgot that I have to join this. Dot join, because I have to pass in a string. So there we go. Now let's try that. There we go. And there you go. See, it reversed the string. Because see, the first time it runs it, it receives the full array. It splits it. Then it receives the array minus that last letter. Does the same thing. It keeps kind of like peeling one letter off and building that final result till it gets to here. Okay, and again, I could have probably been a little bit more succinct as a loop, possibly. Again, I don't think this was like the most succinct version of this I could have written. But you guys get the idea. The idea is that all recursion is a loop. You just think about how many times you want the loop to run and what should it do each time. Like what, and that's like that same thing as like a loop in the sense that you have a condition, but that condition is referred to as your base case. And essentially every time the function runs, it's going to check, is the base case true? If the base case is true, then it's going to end the function and stop with the recursive calls. And if the base case is not true, in this case the base case being that the array that's being passed in is empty. So once once the string is essentially an empty string, it stops going forward. It then just returns what you've accumulated so far. Okay, now the reason why this is useful, because there are languages where there just aren't loops. You're expected to do loops through recursion, like OCaml. Okay, there aren't loops. There's just recursion. So you want to loop and repeat something over and over again? You need to write it recursively. So understanding how to write recursion is not a bad thing. It's not necessarily always the better way to go, or even usually the better way to go if you have the option of loops. But there are going to be situations where recursion just might be easier. Typically, if you're working with sort of like branching tree-like structures, where you need to work down, where you're not just looping over like one thing. So like let's just do an example, like a flatten. So let's like write flatten. So flatten's a good one where you want to do sort of what am I saying? Where you'd want to do sort of a recursive loop. So const new flatten. What flatten does, it takes an array and flattens it. It already exists in, that's why I'm calling it new flatten. But what you do is you pass in an array, and then you're going to loop over it. Okie dokie. And then we're going to intuitively just kind of pass in a second argument called empty, which will equal an empty array. Most people don't need to know about the second argument. That's why it has a default value, but you'll see why we need it in a second. And basically what we're going to do, we'll use the array.forEach for each element. What we're going to do is we're going to say, okay, each one has an item. And we're going to loop over each item. Cool. Now we're going to say if the item is an instance of array, so it's created by the array constructor, then what I want is to run flatten again on that array. New flatten. We're going to pass in the item, and we're going to pass in empty so far. Okie dokie. And else, okay, and that's new flatten. So let me just, not new flatter. And if it's not an array, we just want to push the item into empty. So empty dot push the item, because the idea is we don't want no arrays inside of arrays. We want to flatten the whole sort of spectrum of arrays. And once it's done that, after this for each has been finished, we just want to return what empty is. That should be the new flattened array. Okay. So see, it's recursively running the function, and I'm not returning any value from those recursive calls, so I don't really need to use the word return. but those recursive calls will still keep pushing into this array. So if there was like arrays upon arrays upon arrays, I don't have to write a bunch of nested loops. Okay, because otherwise, if I were to do that with loops, I would then have to say, okay, if it's an array, then I have to write another recursive loop or another loop, a nested loop for that array, and then keep testing it for every level of arrays. But here, this will just recursively work its way through however number of arrays that we have. Like, let's test it out. So let's console log the result of new flatten. And I'm going to pass it an array. So first we'll just try it with a simple one. 1, 1, 2, 2. So there was one array inside the array. And let's see if it works. Okay, and see, it flattened the array. Okay, see, the array is no longer an array instead of array. So now let's make it even more complicated. So now we'll say 3, 3. And then another one, 4, 4. And let's see. And see, it turned it all into one array. So even though I went 4 layers deep, because basically, again, there wasn't just one path. Any of those things in the array could have been another array, and any of the things in those arrays could have been an array. So you're building like this tree-like structure where it's not really obvious how many nested loops you're going to need and all that stuff. In a situation like that, that's where recursion really shines. So think about like a lot of the functions you use on the DOM. Okay, working with, because the DOM is just literally one giant tree of like HTML nodes. Most of those functions, I'm going to assume, are like query selector, etc., work recursively. I'm pretty sure for a fact that when you're using React is using recursion to render all that JSX. So like when JSX gets transpiled, it's just literally like recursively creating a tree of React objects, of React elements based on your JSX. It's just running through there and then creating like, okay, this is a child of this and this is a child of that. Does this have children? Does this have props? And just recursively works its way through the JSX. Okay, so that's that. Yeah, I think that gives you a good wallop of recursion. So you can use recursion sort of as a loop, as we did before. You can use recursion, and that for the most part it's a loop. But you can use it for like tree-like structures where basically the alternative would have been using a lot of nested loops. Instead of using just one structure that just kind of determines when to run the basic logic again. So my name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy. I'm going to call this my Recursion Masterclass. Have a great day and enjoy.